All right. So basically, I started using async await like 5 or 6 months ago, and just kind of noticed some patterns, and thought it'd be useful to show to people who hadn't really used it much. Um, just help you get bootstrapped. The first thing that you should know about async await is that there can be hidden errors. So in this example, we're doing an HTTP GET, and there's nothing wrong with this function except for that this server is not actually running right now. And so when we call main, uh, it it calls this function and tries to store the result into data, and then it's going to say, "Oh, we got the data," and what happens? A big fat nothing, which really stinks. That's not what you want. You want it to fail with an error message at least. So how do we fix that problem? Well, at the top of files that use async await in the entry point, like so not in library functions but in the entry point, I usually put this, and then it just throws the error. So otherwise this code is the same, and then what happens is this, and you get a useful error message. You could also, in the previous example, if you really wanted to do something like dot catch, that kind of thing, and then that would catch the error too. But this is all about uncaught rejected promises. All right, so this is just how we do async with promises without async await, and this is just a comparison and contrast. So the first thing you do often in functions is you'll create a variable to kind of store your state that you're going to use inside of the promise chain, which is just a little bit awkward to like have to create it up here, and then maybe you don't use it until lower down. And then you call this first, and then you'd think maybe this should run second, but no, you're wrong. This is second, and then this is third. And so you just have to know that and structure your code in such a way that you don't get out of order operations. And so then this is what it looks like with async await. This happens first, this happens second, this happens third. You don't have to do any kind of I don't know if it's not hoisting, but you don't have to declare your variable so that it's a more global scope ahead of time. You just declare it where you need it. So this yields readability, cleanliness, easier to maintain code, and so forth. This is just an example of what not to do. In this case, we have a library function that's unnecessarily doing 2 remote calls, and it's just basically be efficient. This is even without async await or promises. This is just a bad programming example. And so then when you run this promise or asynchronous function, you end up getting the config more times than you need to. Instead, it's better to get it once out here in main, and then pass it in to each async call that uses it. And then this is kind of a neat example right here, where we're starting the remote call three different times with 3 different keys, and we're just hanging on. These are kind of like references to that remote call. And then when we want to actually get the values for those remote calls, we can destructure it in this form by using promise.all. And we just pass in the array of the promises. And then it doesn't matter which order they resolve in. The order is going to be maintained. And so you're going to get value 1, value 2, and value 3 corresponding to key 1, key 2, and key 3. So that's a very helpful pattern to use. Something useful that I found while testing is sometimes you, especially when testing, you start doing a decoupled remote operation, and it's not really clear when the operation's going to finish because maybe there's not really a clean hook for it, but it shouldn't take longer than a second or 5 seconds or whatever. Well, now we can do something like sleep in a synchronous language, but we're doing it in an asynchronous language, which is really neat. And all you have to do is import Bluebird, and then use promise.delay or bluebird.delay with the amount of milliseconds you want to sleep for. And then this code won't run until a second after this begins sleeping, at least a second. Here's another kind of performance optimization pattern, and you can ignore the kind of setup here. This is kind of the gist of it. So we are creating this, we're running this function which returns a promise, and we're storing the promise here in output queue defer. And then we're not using it right away. We're letting that remote operation happen. In the meantime, we're doing some work that takes some time. And then chances are by the time we get to this line here, or the interpreter does, then that remote call will be done already, so we don't actually wait at all on this line right here. So the idea is you just fire off remote calls in kind of a performance optimal fashion, and then you do other things that you have to do while you wait for them to return. It's just a little performance or speed boost, I guess. All right, so in summary, use promises everywhere or async functions. If you guys are using promises right now but not async await, transitioning to async await is going to be super easy. So I really encourage you guys to use promises if you're not. Yeah, minimize the number of remote calls for a function. Yep, that's it. Here's a blog post that kind of goes into maybe a little bit more detail at times. Thank you very much. Any questions? Sure.
The whole like const. If you as a constant, I guess it wouldn't.
You're saying if you.
Yeah. So if you like await, or yeah, if you if you wait a value coming out, and you have
like
that,
if you do that.
Yeah.
I'm not sure what would happen. I'm not sure how much const is enforced on the object. It's not.
Right, and that's what I'm wondering is, will it yell at you? Will it say, "Oh, hey, this was referring to the promise, and now it's referring"? But I guess not, because
from the way I read it, the object reference. Which is also like variables equal.
Good to know. Any other questions?
There we go. Hi, everybody. This is production node. There we go. Okay. So, I'm Brady. I work at a company called Brady Verify. So I was having a discussion with a friend of mine about various programming languages and stuff like that, and this is the metaphor he came up with, and I thought it was like super apt, which is Node is basically exactly like that guy from Fury Road who goes and spits gas into the supercharger at the top of the car to make it go faster. That's kind of what Node is. So do a little bit about just some architecture stuff you guys probably already know, so I'll keep it brief. But the way that Node wants to work is you are it's running in one process. You're setting up a whole bunch of requests where you say, hey, read this thing, write this thing, write this thing, and then when you've read those things or written those things, call these various callbacks. And that's the entire event loop right there. And so what that ends up being is like super duper high performance. So where it starts to be not as good is when you're dealing with high CPU intensive stuff. Node really wants to do I/O. It doesn't want you to sit there and churn on the CPU. It'll really start to fall down if you hit it too heavy on the CPU without doing some sort of clever thing like forking or having worker processes and stuff like that. Also, if you have a big, gigantic, crazy amount of code, it starts to get unmanageable. Also, don't use it just to serve files. That's in some circumstances you can do that, but a regular web server is going to completely destroy it in terms of performance. So there's no point. I also would say that if you're just doing a standard issue MVC app, like what you would normally do with like Rails or Laravel or anything else, I wouldn't bother doing that in Node. You're not going to get enough of a benefit, and those other environments are just a lot more pleasant as a programmer to use. And also, if you hate JavaScript, you're not going to like Node very much.
Something.
Yeah, sure.
Yeah, CPU or memory
Yeah.
work. Yeah. Like hardly any memory at all, it'll crash.
All right. So, thus, to your point, what will happen is Node will crash on you at some point. So, basically, if you have anything in your code where there's some exception that for some reason you didn't foresee, and a lot of the time it can be buried in some sort of library that you didn't realize that you were using. Like I've had something where I was doing something with, I think it was MySQL or something like that, and then it threw a DNS error at me. Or I was doing something with SQS and I got some other crazy error. When that happens, it can crash, and certainly, especially if you forgot to catch that particular error. And if you're doing, you're not doing what they call Pokemon exception handlers, where you try and just catch everything, then it's going to be hard to go and list out all the possible exceptions that can happen. Because if you do something at high enough concurrency, something that happens one every 100,000 times is going to happen all the time. And so the problem is that if you have like I said, it's high concurrency. So if you have a ton of connections that are all processing at the same time, one connection has something that goes slightly bad, everything falls down. And this does not happen in like your conventional environment. So like if you're doing something in like let's say PHP and you screw something up, you may get a 500 error page for that one request, but all the other requests that are running on the server are fine. So basically, that same event loop that I was showing before, imagine there's one little request of the thousands that are running right now that has something that goes wrong where you didn't catch the error. Well, now everything is dead. So this is the stuff that we do, basically down from the code level and then working our way out towards the cluster level of advice we have on how to run the stuff in production, dealing with that sort of crashiness and high. First off, some really nice tricks for testing. If you want to actually see this stuff yourself, make a really simple URL that you can hit, call it something like crash me, make sure it does not run in production, it only runs in development and test mode, and then make that just force an exception to happen and don't catch it and watch the server go down. And then also make yourself a sort of a long-running URL that it just sits there, sleeps 30 seconds, and then says, hi. And that's it. And run curl a couple of times against Node, hit the crash me URL, watch all of your curl connections say, connection dropped, connection closed. So again, for the code stuff, I definitely say use strict all the time, and nerd fight, sorry, it's going to happen. I like event emitters for modular code. I think that it ends up being that you have something that's really extensible, and then you can emit a whole bunch of events that you're not even listening to because someone else may want to listen to them later, and then it's relatively easy to troubleshoot. Occasionally I'll use just a straight naked callback, and that's if there's only one thing this thing is ever going to do, and then I don't need to do an event emitter, that whole on, listen, all that other business. Just use a straight naked callback for that. I don't use promises, and that's because in a lot of the situations I'm working in on the back end, you have nested if-thens, and you need all those elses. And where you say, okay, if this thing happened, then close this database connections. If this thing didn't work, then return this SQSQ entry. If this thing didn't work, then unlink the file. And then if you have a big nested chain of promises, that else clause at the end where you're catching everything ends up being really tough to deal with. And also, I found it hard to debug. Now, I'm probably being an old fart on this stuff, and I would say if there's anything in my talk you really want to ignore, you can probably skip that one. Now up to package.json. Don't use unconstrained versions. I know of someone who did this and deployed it, and then I think the MySQL driver changed, and then I had to go and fix the thing that I blew up because the new version of MySQL was getting installed and none of my code was compatible. So that was stupid, and I shouldn't have done that. Don't be dumb like me. Consider using npm shrink wrap. That is something I actually learned about at one of the San Diego JS meetups, and that can be helpful too to constrain your versions. Another thing I would say is that occasionally, every now and then, you should do an npm ls. Look at the list of modules you're using, and if that number is higher than 1,000 in your production app, you're going to end up having a bad time. So I've dealt with a lot of DevOps people, and they always complain about NPM, and I'm like, I don't get it. What's your problem with NPM? It works all the time for me. And then I realized because their apps are using all sorts of crazy libraries that require all sorts of other crazy libraries, and then there's internal conflicts and all sorts of other stuff happening. While I do npm ls on one of our major packages, and it's 200 or so libraries, and that's it. Anything that you start using gulp in production, it's going to be 1,000 or more. I like gulp, but I just use it on the dev side. I wouldn't want to use it in a production Node app. So now up to how to configure for performance. Probably the first thing I always do is check your file descriptor limits. So it's ulimit dash something. I don't remember which letter it is, but that's the number of open file descriptors. If you're running Node and you're running at 1,000 or 5,000 level concurrency, you are going to run out of file descriptors really fast unless you change that. Also, in the old days, this is not as much an issue anymore, but in the old days, the HTTP client that was built in had a 5 connection limit to every IP address. And that was a huge sticking point for a lot of stuff. They've changed that in, I think, version 0.12 and later. But if for some reason you're stuck on an older version, make sure to manually change the max number of sockets. Also, it may sound obvious, but you definitely have to do it, is make sure you're pooling your database connections. Don't try and just open one database connection and then slam it with 1,000 some odd concurrent connections. Also, if there's anything else you're doing like Elasticsearch, SQS, you're going to need to pool that yourself. So, now, as I mentioned before, Node will crash on you, so you need to have some way of automatically restarting it. I like old-fashioned tools because I am old, but there's all sorts of really cool new stuff that does this a lot cleaner than the way I do it. But I've used daemon tools. I use Etsy and Knit a lot of the time. It basically restarts the thing. I say, keep restarting 20,000 times, and it tends to work. But I don't really care. It can be anything so long as when Node crashes, it gets consistently restarted. So now another code thing. and this is domains, which unfortunately is a word that we crazily overload in the computer world. In this particular one, it means error domains. This is a feature that for some reason is listed as deprecated. Deprecated level 0, go away. However, this thing is it's super powerful, and if you're using Node in a really high concurrency environment where, like I said, those errors that are almost impossible to happen will happen every day, being able to wrap everything in a domain can be amazing. So what it does is anytime there's an error that's emitted or an exception that is thrown, it tries to constrain it down to just that one connection. The Node docs tell you is like if you catch anything in a domain, what you should do is be prepared to shut down the entire server, but you can shut it down gracefully, as opposed to having all of those connections all drop at the same time. You can have the one connection that errored, you can return a 500 there, you can stop listening, allow, maybe set a 30-second timeout, let everything clear out, and then shut down, and then let your restarter restart you. Some middleware packages may be doing this for you already. If so, great. If not, you should check it out. So here's a really simplified example. It's basically you have to require domain to get it, and then you simply associate this current connection. So you can see I'm doing request add, and for the request and response, I'm adding those streams to the domain. And what that's going to do is, if, like I said, so we have 100 connections all running at the same time, one of them something goes terribly wrong, I haven't managed to catch the error somehow because it's something I've never seen, it's something I wasn't expecting to see, I can drop the 500 there, let everyone else finish out, let it restart. This is kind of boring, but you have to do it. You probably want some sort of centralized logging, some sort of way to go and catch all of the things that are going on. I like saying something simple in the logs so that you can see if you have a restarting problem. So we have our node set up, and we have it automatically restarting. We want to know if node keeps restarting 20 times an hour. That's a problem. So I like to put some sort of special sentinel message in there I can catch. So now on to what types of servers you're running on. I think that your safest bet is small. I would say it's far better to do many small than a few large. Ideally, if you can do single CPU, then you can skip out on having to use node cluster, and that's a whole array of problems you don't even have to worry about. Unfortunately, Amazon doesn't really have those good single CPU instances. Almost everything is 2 CPUs, so in a lot of cases we just ignore the second CPU. But you could certainly, you can use node cluster, and it's fine, but there's just a lot of little gotchas in there. Like if you had a data structure in one, and then you've forked out processes, and now you have 4 different data structures because they're all different processes, it gets a little clumsy. So if you can avoid it, it just makes your life a lot easier. So on Amazon, we do a lot of T2 micros, M1 smalls, T2 smalls. Basically, we'll do 16 little ones as opposed to one giant one. So now up to the array level, I would say you definitely want more than one server, no matter what. It's just Node being as powerful as it is, but as unsafe as it is. I want to have always at least more than one server to go and be handling all of my traffic. You definitely want some sort of health check. Application level as deep as you need to go to determine that your Node app is not unhealthy. I'm a big fan of Amazon autoscalers and elastic load balancers. I think those are they're just great. I love them. And that's it. I am Uber Brady on Twitter. I am Brady on San Diego JS Slack, and there's my other contact information, and that's all I got. All right. Any questions or anything?